Welcome everybody back to Differential Equations, and today we will be rocking out the Bernoulli equation. This video will be very short, and it will be very simple. We will just be showing you this very specific type of differential equation. Alright, let's rock. So, what is the Bernoulli equation? Essentially, it's a nonlinear equation. Okay, so we have our derivative plus a function of t multiplied by y, and this is equal to another function of t multiplied by y to the n. So if n is equal to 1, this becomes separable. And if you guys don't know what separable differential equations are, I recommend checking out my previous video. It explains just that. And if this was to the power of 1, we can just move this on to one side, factor out the y, and rock out. However, it will not. So we must multiply by a factor. 1 minus n multiplied by y to the negative n. So first, when it comes to y to the negative n, that makes sense, because now we're getting rid of the y on this side, so this can become a pure function of t. This becomes y to the 1 minus n, multiplied by 1 minus n, and this becomes 1 minus n times y to the negative n, multiplied by your derivative. However, notice something. And that is this, so very good. Okay, of course. And I did forget, we will have to multiply 1 minus n on this side too. Obviously, you have to multiply both sides of the equation with the exact same thing. Okay, now, this is where it gets incredibly interesting. This looks like a just absolute mess. Guess what, though? We could use a different dimension. Use a different universe where we're going outside of y and we're going to u! U! Boom! Genius, isn't it? Bernoulli is very genius, and I believe he taught Leonhard Euler. So, by the way, Euler is the genius of genius, and look, these guys are genius. But first, let me just explain this. So now, this makes perfect sense, doesn't it? Y to the negative n, 1 minus n, times this, slip it into this, boom, 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 y to the 1 minus n is u. We'll define that. Maybe please define it. Yes, okay, boom. So u is y to the 1 minus n, and you find out that this is just the derivative of y to the 1 minus n, which is this. d dt of u, du dt. Baby! Cleans this up. This doesn't become some slop, it becomes u. And now this becomes, guess what? Integrating factor, first order differential equation. Let's rock out, baby. This is an example. Well, what are we going to do? It's quite simple. That is right. We're going to multiply it by 1 minus n, y to the negative n. Then we're going to also slip it. I did do this in the same step, actually, where I did put it into u. Obviously, as you guys can see that. It's actually incredibly simple. Simplify this up, baby, and guess what? This problem's easy. We just rock out with the integrating factor. Solve it. Yes, so this actually looks like almost integration by parts, but guess what? The natural log saves our ass. Saves us like insanely good. And yes, evaluate this integral. Solve for u. As you can see, natural log absolute value of x plus c divided by x squared. Multiplied by x squared. Excuse me. Divided by 1 over x squared, rather. Obviously, we're not looking for the solution in terms of u. We're looking for the solution in terms of y. But recollect, our u is equal to y to the power of 1 minus n. What is n? It's 2. So u is equal to 1 over y. And, you know, sometimes it's like, okay, u is equal to 1 over y cubed, whatever it is, you just solve for y. And that's it. It's awesome, isn't it? Like, wow! That's, like, genius. Excuse my language, I'm gonna have to cut that out. Yeah. So, look, rock out. I just showed you this. It's pretty awesome, and I'll see you in the next video.